recording here. So far we're good. It's Crewwitz. All systems are go. All right. So what we were doing, I'll throw letter B up real quick as a little review. And then if you remember what we were talking about yesterday, Cam, you can walk us through what you think is going to happen in D, okay? So when we look at this little square at the top, so this guy, the only way that's going to become an x squared from multiplying a base and a height would be if these are both x's. So we would have called both of those an x. The only way that you're going to be able to get a 25 as a base times a height is from this length being a 5 and then this length being a 5. Turning this over. And then what that allows us to do is fill in these other rectangles. This has a base here of what would have to be x. It has a height of 5, so we would call that 5x. This has a base of 5, that same length, and then it has a height of what would have to be x, so this is a 5x. We talked about how when these are perfect squares, what happens in a perfect square is these always end up being the same. In this case, they were both 5x's. And we could then go ahead and say what we had here was an x plus a 5 multiplied by an x plus a 5. Instead of writing it that way, the way we were writing this was the x minus 5 quantity squared. And then we were just trying to figure out how can I multiply that out without having to do boxes, without having to do all the foiling and combining like terms. So we started talking about how the little shortcut will always get this squared term, and that's from here, also in our area model. We're always going to square the 25. We have that here, so we always get that as our final term. And then whatever these two guys multiply to equal, which in this case is a 5x, those are what you're going to get 2 of. So notice how we got 2 of those. So the middle term would have been a positive 10x. That's what we were wrapping up. That's what we did a few of yesterday before the bell rang. All right, so now Cam, we'll see. After a 24-hour layoff, Cam can knock out number D for us. So what do you think there, Cam?
All right, so I'm going to give you A and B.
Hold on just a second. Let me turn you up so people here can hear you.
Okay.
You're on my computer today. Now it's not up there, and I don't know why. Okay, go ahead. Hopefully you're loud enough now.
All right, I'll give you A and B first. So for A and B, I had 9x plus 2. So that's like going across the top.
So here.
Yep.
And then here. Okay.
And then for C and D, I had 9x plus 2 again.
That. Okay.
Yep.
So let's stop there and let's check Cam's work. So right now, if you're kind of understanding, think, is this something that we would have? Does this make sense for what we are trying to set up? So let's do this first, Cam. If I'm going to do this guy here, I would have to take this length here, which would be your 2, and we'd have to multiply it by this height here, which is 2. Does that product give us the 4 like it's supposed to?
Yeah.
Yeah, so Cam's good with that one. If we go to the next one, in order to get this little one, the squared one, what is a 9x? Because we'd multiply that by this guy, 9x. So would a 9x multiplied by a 9x, for those who can't see Cam, he's grabbing his hair now, can that give us the 9x squared?
No, it's going to be 3x.
All right, good. So yep, that's okay. You caught it, right? You understood it. So this is 3x. That has to be a 3x, because now when we multiply those together, that's going to give us a 9 and then that x squared. All right, so good. All right, then from there, we should be able to fill in this upper right-hand corner now that we have the sides all filled in. This is going to be a 3x. This has to be a 2. So now if you had that corrected, Cam, we get a 6x. And then same thing here. This is a 2 for the height. The base right here would have to be the same as that 3x. Those multiply together 6x. Again, not coincidentally, these guys end up being the same. So now look at our shortcut in this case. We had 3x plus 2 twice. So I'm going to just put the squared on it. Think about our little shortcut that I think most of us were starting to understand yesterday. If we just kind of recall it today. We're squaring this first term. So that's the 9x squared. We definitely got that here. We are going to square the 2. That's our last term. That's the 4. We got that here. And if we had just multiplied these two together to get a 6x, is that what we get 2 of here? Yeah. So then we would know we would just do a plus 12x for that middle term. All right. All right. So now on to our next sets. So now this is now going to kind of ask you for you to recognize a new little pattern. So it says find the missing value that would make each trinomial a perfect square. All right. So if I gave you this, x squared, 6x, what would our constant have to be? So actually, let's use this one that I have blank. So let me, don't necessarily change yours, but you can just look at my screen. I'm going to delete this out. And then we'll use the area model to kind of show what pattern you're looking for. There we go. All right, so we have the x squared, right? So here's our x squared. So that would have told us that this is an x, and then that is an x. The middle term is 6x. So take a second, think this through. We did a bunch of them yesterday. It would have been nice if we were able to get all these done in kind of one day and not have that 24-hour lag in between. But think about if the middle term was 6x, which it is. So if this middle term is 6x, that should actually allow us to fill in this part and that part. If the middle term is 6x, write down what you think these two rectangles would have to be.
Should be 6.
Who said that? Is it Ahmad?
I did.
I like how you say that. Ahmed. All right, Ahmed. All right, what do you think?
I'm thinking a 6 because 6 times x is 6x.
So a 6, right? Let me see here. So a 6 in here, you're saying?
Yep.
With the x. So does that mean there's going to be a 6x here because these have to be the same? Is that right? All right. So now think about what that would mean, because don't we then add these together to get the middle term? So if I add those two together, is that giving me this middle term right now?
Oh no, I think because 6 plus 6 is 12x.
So what should it then be, Ahmed, if that's going to give
Should
us?
have been 3.
Good.
If that's the case.
Good. Those have to be 3x's. So if we understand that, what we are really doing is an x plus 3 here and an x plus a 3 right here. So now, ultimately what the question, the blank line, is this constant value. What does that constant rectangle then have to be if we have the 3 and the 3? Ahmed?
Should be a 9.
Good. So we're going to be tacking a 9 on right here. All right. All right, I want to do one more with the area model, then I want to see if we can kind of understand a little shortcut. So skip B a minute. Go to letter C. I want to do a few of them all that are similar all in a row so we can recognize this first little pattern. All right, so I'm going to erase this again. We're going to use this one more. You know what? I'm going to draw a new one because I want you to see this. So while I'm going to do that, see if you can figure this out. Whether you do the area model, go to letter C. Understand what we just did in A, and see if you can do this. Because I'm going to clear a space here so we can use the rectangles. Okay, hopefully you have a thought in your head at least, or you have a process or something you're doing. If not, we're going to do it now, and then we'll see if you're right, and then we'll do a few more. We're going to hopefully talk about the little shortcut or pattern you're going to see here. So if we have this x squared, then this is the easy one. The one that's the square has to be an x and then an x. All right, so then Ahmed here a minute ago, when he did that, he actually put the 18 here and here. In this case, it'd be negative. And then he realized that wouldn't have worked because if we add those up, it's going to be much bigger than the 18. So notice he set 6's here first, and he cut that down to a 3. If we thought that same process, 18 and 18, that's too big. All right, do we all agree that has to be a 9? Both of those would need to be a 9. So think about what that means. We're taking this 18. Oops. In order to figure out what those middle terms are, we're taking that 18 and we're going to turn it into a 9. So put 9x's here.
It would be negative 9, right?
It would be negative 9. Yes, thank you. Forget that. Definitely negative 9s. Think about where that came from, though. Didn't we take the 18 and basically cut that in half because we're putting it into 2 different spots? Same with number 6. Didn't we or letter A here? Didn't we take the 6 and cut that in half because they've got to go to 2 different spots? So what we're doing, whatever number we're given, and Ahmed, I'm kind of glad he did make that little mistake at the beginning because it reiterated and made a good point that we need to cut that in half because they've got to get split into 2. So that's where these numbers are coming from. We're going to cut that in half. So then now think, doesn't this have to be a minus 9 here and a minus 9 here? So what is this then, Cam? What does the big square have to be?
81.
81. So now, moving forward, we'd like to not have to draw the squares every time. So we've got one of the 2 parts of this little shortcut. And the first shortcut is, whatever this middle term is, we've got to divide that by 2. When we divide that by 2, notice how this one gives us a 3. This one gives us a 9. What would I do to 3 to get a 9? What do we do to 9 to get an 81? It's the exact same thing.
Multiply by 2?
Not by 2.
I mean by 9.
Okay, in this one it'd be by itself, right? By 9? Because don't we end up with a 9 here and a 9 here?
Yeah.
Well, what's 9 times 9?
81.
81. So what we're really doing, 9 by itself is really just whatever that number is, we're squaring it. When this becomes a 3, don't we get a 3 at the top and a 3 at the bottom? So we're really multiplying it by itself. So we're just going to do 3 squared. That's how we can get that 9 very quickly. All right, so let's find one that is like that. There isn't one because probably for that purpose. At least we don't want to do E just yet. Add a G and tell me this one. X squared plus 10x plus what? And try not to draw the area. It's a nice model, so quiz, test, you really want to do that to make sure, but we'd like to just be able to go right to this. All right, what do you think, Cam?
Plus 25.
Perfect. All right. The 10 would have had to get split up between 2 different rectangles if we drew that out, leaving us with 5. So now we have a 5 on the top, 5 on the bottom. Those that get multiplied together, we're really just squaring it, and that's going to give us our 25. Okay. All right, the next one that is like it is E. So let's do E real quick. You won't like this one quite as much, but it's the exact same setup. We have to take 5. So if we actually had our little rectangle model and we have the x squared here, then we would have to cut this in half. Now as a decimal, maybe you'll like the decimal a little more because it actually makes sense if that's half. So we cut that in half. You'd put 2.5 here, 2.5x here, and then that now is what's going to get multiplied by itself for the base and the height of this rectangle here. All right. So as a decimal, when we square this, you would get 6.25. All right. All right. Now let's go backwards. So now having done those, see what you think about B. Now we want the middle term. All right. Anybody feeling lucky here? Ahmed, what do you think, Ahmed?
I think it's going to be negative 20x.
Ahmed says, oops, negative 20x.
I guess it's minus 20x, whatever word.
Okay. Yeah, that's fine. Do we agree with that? Cam?
I'm not too confident in this, but actually no. Let's go with 20x. I want to see how this goes.
All right.
Okay,
So
I'll explain why I got 20x.
All right, explain, Ahmed.
Because I did negative 20x divided by 2, which is going to be negative 10.
Because we have to cut that in half,
10
right?
times negative 10, which is technically just 100.
Good. Perfect.
good job. Okay, that makes sense.
Yep. We square negative 10 to get to 100. And the negative 10 would have come from us cutting that middle number in half. Because in our square, we have to put 1 in the upper right-hand corner, 1 in the lower left-hand corner. They have to be the same. They're both going to be a negative 10. But then that's what you would then multiply together to get the big rectangle down here. You would have had a negative 10 here. You would have had a negative 10 here. And then that's how we can get our 100. All right. Very good. All right, letter D. See what you think for letter D. Similar. Is Jamila? Do you see Jamila's at home right now? Oh, is it not on there anymore? Yeah. Okay. Okay. I'll change my seating chart. All right. What do we think? Calling somebody here. Fortunately, I can only see 16 of them. Anybody feeling good? Yeah. I'm gonna go Vicky because I'm not worried about embarrassing Vicky. What do you think, Vicky?
24.
Oops. All right. Vicky says 24. We agree with Vicky. You're getting some good head nods, Vicky. Yeah. Good. Should be 24. That's what we would have to cut in half to get 12 into each square, and then they would have gotten multiplied by themselves, and that's what's going to give us the 144. All right, good, perfect. All right, do I want to do that one right? Yeah, let's do letter F. I might suggest using the area model in this case, but take a minute and see if you can get this one. A little trickier. The little rectangle and the areas might guide you a little bit with this one the first time where we don't have a 1 in front of this. Because it's not quite as simple with this one. Bigger for you guys in here. So know what 2 boxes you're given. When you're given this first term or the last term, you're given these 2 boxes. And because of that, we should be able to fill in everything around it, allowing us to get the 2 boxes here that we ultimately need to add up to become our middle term. Oh boy, okay, let's see what we got here. We'll walk through this one together. In order to get a 4x squared here, these would both have to be a 2x and a 2x. That's what would multiply together to give us 4x squared. To get a 25, again, these have to be perfect squares. That's why all these have to be the same. So the only way I'm going to get a 25 is if this is a 5 and that's a 5. We then know the middle term right here should be the sum of the two missing squares right now. So if I can figure out what these are, I'm going to add them up. That has to be this middle term right here. Now that we have the perimeter, we should be able to do that. This base here has to be the 2x. The height would have to be a 5, so this would be a 10x. This base here has to be this 5, and the height would have to be the 2x. It is also a 10x. So, if you did it correctly, really good, because it's a little trickier when we start dealing with numbers that are not a 1 in front of this, you would have got, and these should be minus, I suppose, but you would get a minus 20x if you did that correctly. All right. All right. Next one. I think this is the last type I want you to do. Yeah, that would be somewhat new. All right. So now we're giving you the area equation, and we want you to come up with what we multiplied together to get this. All right. So again, let's do the area for the first one, and then see if we can recognize this pattern. This is your x squared. This has to be 16. All right. So this is our squared term, has to go here. The constant has to go here. So then we hopefully then know that each of these, we're cutting this in half, they have to be allocated between those two rectangles. So this would have to be a negative 4x, this would have to be a negative 4x. So when they add up, you'll get a negative 8x. If we then fill in the outside, this would be x, this would be x. This would have been decreased by 4. Same down here, this would have been decreased by 4. So what it's asking you when we ask you to write this as a perfect square, what that's saying is, instead of saying that this is x minus 4 times x minus 4, which is totally correct, we have a x minus 4 on top, you have an x minus 4 on the bottom, that's totally correct. But when we ask you to write it as a perfect square, that's just saying instead of writing it as a product, whenever we multiply something by itself, we can just write it as the power squared. That's what it would look like if we asked you to write it as a perfect square. All right. Okay, so with this one, if you think you need to do this, go ahead. Long term, we want to be able to kind of just look at this and understand where this was coming from. So we should have something in here, quantity squared. All right, Cam, what do you think?
X plus 13 squared.
Do we agree with that? All right, good. A lot of people saying yes. Hopefully that means a lot of us are getting that. X squared is the x squared. The 13 squared is 169. If we multiply those together and we have to double that, that'll give us the 26 in the middle. All right, good. All right, last one of the kind of new thing. See what you think for this guy. Same thing we did in A and B. Don't freak out now because it's a fraction. All right, and then let's see what we have. Let's go over A. What we really just do with these, we're cutting this in half. That's going to give us the 4. And then 4 squared is what gives us that 16. And then notice, it's x minus a 4. We're cutting the 26 in half. That's giving us a 13. The 13 squared gives us the 169. But look what we have here. Whatever we're dividing this by 2 with, that's what's going inside of our parentheses. So for this one, same exact thing. If I divide this by 2, And then I would do 7 halves squared. This one we have as a fraction. So 7 squared is 49. 2 squared is 4. That's our last term. So what's going in all of these? When I divided this by 2, that's 4, right? That's what goes in my parentheses. When I divided this by 26, that's 13. That's what goes into my parentheses. So when I take 7 and I divide it by 2, that's what goes into my parentheses. So that should have been, so if you got this, good. Get this back on the screen. That should have been your x minus the 7 over 2 quantity squared. All right, so just that middle term cut in half. All right, real quick, let's knock a few of these out just to make sure we have this down. This is the easiest one. Let's do one together again real quick. We just want to complete this square. Like what could we tack on at the end to make it a perfect square? So for number 1, what we're saying we need to do is whatever this number was, and this is again Ahmed's question. I was kind of glad he missed it actually that first time because he understood I can't put 18 in both. They both have to be 9s. So the way we can do that without the square is just divide by 2. We got to cut it in half. That then would have told us we have 9 everywhere. So then whatever we get with that, we're squaring. So 9 squared had to be 81 because I'd have a 9 here and I'd have a 9 here. We need to multiply those. All right. One more, and then I'll start calling on people, see if we have this. Next one, we're going to cut this in half. We'd have to put those 10 into 2 different rectangles. Each of them would be the -5. But then in that constant square rectangle, we would have multiplied that by itself. So this should be 25. Okay, I'm going to give you a minute. Do 3, 4, 5, and 6. Let's see if we're understanding those. If you get them all right, I'll let you out early. Yeah, right. Although 7 is a fraction, so maybe and 8. Actually, all the rest of them are fractions. Yeah, go up to 6. Although 3, you may need a calculator. See how good you are with your multiplication tables. All right, go about 15 more seconds here. All right, Cam, you had your hand up. Is that for number 3?
Yep.
All right, what do you got?
169.
Good. We're just splitting that into 2. If we do our rectangles, we have 13 in one, 13 in the other. And then those would have gotten multiplied by themselves. So that gives us a 169. So you would have had that -13 squared. 4, Jenna. What do you think, Jenna?
64.
Good. We would have cut that in half. We would have had 8 in 2 different boxes. And then as those got multiplied together, we should get a 64. 5. Let's do. They don't show their names unless I toggle. Jennifer, what do you think, Jennifer?
81.
Good. Should be 81. We're cutting that in half. That's a 9. Square your 9. Should be getting 81. And who else am I not forgetting to call on? Michael, what do you think for number 6, Michael?
144.
Good. 144. We divide that by 2. Should get the 144. All right. Now, I lied. I'm going to do 1 with the fraction, and then we'll let you go. Don't freak out with the fraction. If it's not a nice number, you're still cutting this in half. So that's 3 halves. You could, if you want, if you don't like fractions at all, and we like our calculator a little bit more, you could write that as 1.5. 3 divided by 2 is 1.5. Whichever way you choose, though, you then need to square that. So the fraction getting squared would be a 9 over a 4. So that's one thing you could put up here if you want. 1.5 getting squared is 2.25 if you like decimals better. All right. But just don't think it's anything different just because it's not a nice number that divides evenly by a 2. All right. All right. So with that, we finally get done with that, and we finally did not have any technical difficulties, which is encouraging. So don't look at those. Real quick. This, you now have homework. We'll do this for Monday. I think I actually have to change it because we're behind. Here's what your homework should look like. Pull this up. It is the 2.4. It's page 17. So this is page 17. You're going to go, I believe it was through 18. Let me confirm that. Make sure I remember that correctly. Yeah, it's just those 2 pages. And you're going to do 1 through 18 of those. So if you have your task or your Ready, Set, Go packet, you can just go right in those next pages. If you don't have that packet, then it's on our Canvas page, and it's just that assignment. So you could just go to, I'm already here, Module 2. Come on, get to it. And then this is our homework if you just want to print that out if you don't have the packet. All right. All right. With that, call it a day and a week. We made it through another one. All right. Thanks, guys, for the good week. Good to meet some of you in the flash finally. But have a good weekend. We'll see you guys on Monday, okay? All right. See you guys.